Do you want to set yourself apart as a software engineer? Do you want to make sure that mission critical features that have bugs never make it to production? Do you want to catch regression bugs automatically before your users even see them? In this video, I'm going to show you how to build an automated regression pipeline. This is a structured, maintainable framework with logging and reporting. By the end of this video, you should be able to implement a regression pipeline into your project and make sure that no mission critical bugs make it to production. So what is a regression test? So let's say you make an adjustment to your code, you add a new feature. We want to make sure the existing code still works the same way. Because every time you add a feature, or you fix a bug, or you refactor something, you take the risk of breaking something even if it's unintentional. So regression tests will act as a safety net. Your CI pipeline will automatically go in and test common workflows that you'd have to your project. And that's what our framework today is designed to do. So what does a framework mean? Think of it as a set of reusable blocks that give your test structure and consistency. It answers questions like, where do my tests go? Where do the page selectors go? How is my browser configured and managed? And when I do tests, where are they logged and reported? Okay, first things first, we're going to go through the repository. So if we look through the repository structure, as you can see at the root level, we have the requirements.txt. This is very common, typically showing all your dependencies to certain libraries you'd be using. So in our case, Selenium, Pytest, and Allure. We also have the config folder in our root directory. This is think of this as our source of truth for basic things such as our base URL, common global timeouts that we want to have throughout the project, like for example, an implicit wait. A very common part of testing frameworks and regression pipelines are the page object models. Think of it as decoupling the page from the code. So as my project is just testing the Google homepage, there are various things that my page object model for the Google homepage would have. It would initially have the locators, but also it would have the business actions. For example, searching for something or clicking search. So now that we're done with the page object model, we then need to know how to execute and keep things stable. So we have the test suite. This is where we write our tests. For example, open Google, search something up and click enter. And then we have the conf-test.py. This is where our driver's fixture is, where we initialize the browser and make sure it always quits at the end so we don't have ghost browsers. In terms of debugging and continuous integration and continuous deployment, we have the logs file. The logs file is pretty straightforward. When you're debugging CI failures, you need to know what's going on. So ideally you write good logs so that when the execution's happening, you can see exactly what's happening. In the case you have a headless browser and you can't actually see your screen, logs are where you can see where exactly things went wrong. Now we have our YAML file, which is typical for a CI pipeline on GitHub. So it makes sure that every time there's a pull request, that the code gets vetted. It means that anytime there's a pull request, the regression environment is ran, and it shows Allure artifacts as shareable evidence of the release. So we're on Selenium 4 now, which is really nice because it has a built-in driver that actually does a lot of the heavy lifting for us. What's good about this is we actually have a headless browser, which means that the browser won't open every time and it actually just manages on its own. This is a lot faster, but the con to this is that you can't actually see what's going wrong and you have to use logs. A good counter to this is that you can take screenshots for every step and see exactly what's going on as if you were watching. So now we're going to look at our page object model for our Google page. So we've already talked about the page object model a bit. This is how we define how we interact with our pages. We have our constructor and our driver. This is where the page object is created. Inside the constructor, we have the WebDriver wait instance. We also have centralized locators. These are always at the top of the file. For example, the search input, the search button, and the results link. This is important because if the UI changes and we need to change the locator, we only need to change it in one spot. We have the open method that would open a specific page. We have the search method. All the waiting and interaction logic is encapsulated here. This is abstraction, which makes tests much simpler. We also have the waiting for results function and the retrieving results function. And both of those are quite self-explanatory. The major takeaway to the page object model is it's a clean interface between your tests and the UI. Now let's look at the actual tests. So for each test, we create the page object, we open the page, and we perform the action. And then we assert if the expected outcome happens. For example, we open Google, we perform a search, wait for the results page, and verify that the URL contains the word search. So we have positive cases, we have negative cases. Firstly, positive cases, these are the good cases. These ensure that things work under normal conditions. For example, we test searching with enter, clicking the search button, using special characters, numbers, long text, but we can use parameterized text to run the same test with multiple inputs. This is super good because it lets us test multiple scenarios at the same time. Then we have the negative cases, which are way more important to think about. This verifies how the system behaves when things don't go as expected. For example, if we try to wait for results without clicking search, we should expect a timeout exception. So now we're going to talk about logging. Logging gives you the visibility to see what's happening under the hood. If a CI pipeline fails, we want to know what went wrong and where. As you can see here, we have a log provided to us over our runs over time, every time we've executed. This helps lots for debugging when things don't go good. You can ask why your test failed, and you can look in the logs and decipher what exactly went wrong. Then we have Allure reporting as well. Allure is good for generating visual reports. These are typically good for stakeholders or business people to justify what's going on. Did all your tests pass? Did some of them fail? What's going on with your tests? And for developers as well, it's a very interactive experience where they can go in, click on specific tests, and see exactly where they went wrong. What's the bug with it? So to make sure that they can push to production and get clean code quick. We can also have a CI pipeline with GitHub Actions. My specific project, I hooked it into GitHub Actions to be able to run the CI pipeline from there. Every time the code is pushed or a pull request is submitted, the pipeline installs the dependencies, launches Chrome, and runs the regression tests. If anything fails, the pipeline fails. This makes sure that regression bugs never make it into production. It also releases the Allure reports as an artifact, so anybody on the team can review it and debug the issue. So we started with structure, then we built the page objects, added fixtures and logging, wrote meaningful tests, generated Allure reports, and finally automated everything with CI. This is complete, ready for production. You can now take this architecture, plug it into your projects, add some new pages, add some new tests, or support additional browsers. This is the foundation for real engineers and how they confidently ship software.